Alright guys, now next thing that we're going to do is we'll be building the episodic memory. So you can just go to memory folder, and in memory we'll be building the episodic store or the episodic memory. Okay, so first and foremost, what is episodic memory? It is an advanced capability that enables an artificial agent to store, recall and reason about its own past experiences or events it has personally encountered during the operations, which is very similar to humans who remember distinct moments from their lives. Okay, just how us humans remember things. Okay, we don't remember things end to end. We kind of remember them in episodes, right? Whether it is past interactions, whether it is the keywords that we can remember from those interactions, what worked well, what did not work well, all of those things. Okay, that is what we're going to design now in episodic memory. Okay, now yeah, you can just read this interesting article on Geeks for Geeks. It's quite interesting. Okay, now what are the importance and benefits of it? Okay, now when we are building episodic memory into our agent, we are going to increase the contextual awareness. Okay, because it is going to consider all the historical experience. Then we're going to have improved learning and reasoning capabilities. We're going to have better planning and anticipation. We're going to have transparency and explainability and safety, which is fantastic. Okay, this is typically what we intend to build in our agent right now. Okay, now here again, as I said, episodic memory acts as a long-term archive of the past specific conversations. It might happen that with our AI system or AI engine, there will be multiple researchers across the world who might be asking different questions around research studies, around clinical trials, all of them. And in order to remember those past conversations, it will be helpful. Okay, so what is the purpose? The purpose here is that it gives the ability to remember what it found in the past analysis sessions. Okay, what is episodic memory? You can think of this as a detective who keeps a case notebook, and every time they investigate a case, they write down what they found, who was involved and what the conclusions they drew. Next time a similar case comes up, they just flip through the notebook and they can just look at that, hey, you know what, we had this case earlier, this is how we're going to solve it. Okay, and that is exactly how episodic memory, or what episodic memory does for our agents. Okay, what is an episode exactly? So that is what we need to define when we say episodic memory. And if our agent is going to remember the past conversations or interactions in terms of episode, how will I be defining that episode in the first place? Okay, so one episode is basically one agent reasoning session. Okay, this is how an episode will look like. Okay, it will have the name of the agent, it will have the NCT ID of that research, it will have the content from that research and the outcome as well. Okay, and this gets saved with the vector embedding of the content, so that the future search, okay, can it find it by meaning and not just the keyword match. Okay, and that is the beauty of it. Okay, why this is a key differentiator? Because 99% of agentic tutorials that you see, they never work on memory. If you're not working on memory, your agentic AI platform is useless in the first place. Okay, now first and foremost, you can just go to your Cloud SQL Studio. Just a while ago in the last video, we ran the SQL commands, right? Now here what we're going to do is, in this clinical trial DB, we're going to create one more table, and that table is going to be called as episodes. Okay, if you see here, we have created one episodes table here, and in that episodes table we'll be having 7 columns: agent name, NCT ID, content, outcome, embedding and created at. Now these columns are going to be populated by this particular file. Okay, so if you see, we're going to create a table called as episodes, and these are the columns that it is going to have. Episode ID, if you see, it's a primary key. Okay, and once you run this, okay, run this also, where we're going to create the index. Now here in this particular file, okay, in GCP commands, okay, you will find all these commands being listed. If not, you can just look at the screen and you can try it by yourself as well. Okay, and then now here I'm just running a simple command which gives me all the table names. Now here you can see episodes table name has been listed here. Okay, so please note, in order to store these episodes, we are going to create an episodes table in our Cloud SQL on the Cloud SQL Studio. All right, so let us get started. We're going to import JSON. Now if you see here, I have commented it very well so that when you actually start working on it, you will understand it end to end. I'm going to import JSON, okay, because obviously you know why we're going to use here, because we're going to have a Python list and we're going to convert that into a JSON string. I'm going to import UUID. UUID basically stands for universally unique identifier. Okay, UUID.UUID4. Okay, so it generates a random ID. Okay, so now we use this to give every episode. Now every episode will also have its own unique ID. That is the reason we are using this. We're going to import date time. We're going to import async OpenAI, async PG, which is the async PostgreSQL driver for Python. Okay, and why do we need async PG? We have already discussed this, because we need to register a custom codec for the PG vectors vector type. Okay, we're going to import settings and we're going to set up the logger. Okay, now we're going to define the episodic store class, and the class is nothing but it's a blueprint for creating objects. So when we are creating the episodic store, okay, that knows how to connect to our Cloud SQL database, save the agent reasoning sessions as episodes. We have already seen how an episode might look like. We're going to search through the past episodes by meaning, and it is going to return recent episodes for API. Okay, now we create one instance of this class and reuse it throughout the application rather than creating new instance for every call. So I'm going to create a class called as episodic store. What does it do? It stores and retrieve agents reasoning sessions as episodes. Okay, you can see we are instantiating it here. Okay, and save what an agent found. This is where we are going to save an episode. Okay, so when we save an episode to our GCS store, you can see what gets saved. So when we say the episode gets saved, we're going to save the name of the agent, NCT ID, content that will be getting saved, and what is the outcome of it. Okay, and how do I search through past episodes? So in the same store, I'm going to see, we're going to have two methods. One is save episode, other is search episode. So from how I'm going to search from the episode. So if you see the query, okay, this is the query: sponsor never posted results, agent name, missing result agent, and top k equals to 3. This is how it is going to search from the episodes. Okay, which is going to create a constructor here. Okay, and then I'm just going to say I'm going to create an async G pool. Okay, now here self pool, what it will do, it will basically hold our database connection pool. Okay, and what is a connection pool? It's nothing but a group of reusable database connections. Okay, that will stay open and ready, which are much faster than a new connection. Okay, we initialize, you can see we are initializing it as none, because we don't open the database connection immediately when the object is created. Instead, we open it lazily, which means when someone actually tries to open it, we're going to open the database connection. Okay, you can see we are using the underscore prefix pool, okay, which is nothing but the Python convention meaning, and this is private, okay, which can be only used inside this particular class, and that is what it means. Okay, then I'm using async OpenAI, which takes the API key. Then I'm using the embedding model, or rather I'm just putting the embedding or storing the embedding model here as an instance variable. Okay, we are going to log it. Then here now you can see I'm going to create the helper methods now. Okay, the first helper method that I'm going to create, or a private method that I'm going to create, is called as ensure pool. Okay, now here you can see every private method we start with an underscore. Underscore means they are private by convention. Okay, these are internal helpers only called by other methods. Okay, so we're going to use, if you see for example this ensure pool, when I use this ensure pool helper method with the store, you would never write this instead, you would never write this, instead it is automatically used by the saved episode. So I'm going to create this async function called as ensure pool. Okay, and Yeah, so without await, Python would not actually run the method. Yeah, what does this function even do? Ensure pool. By the name itself, you might have understood. It just makes sure that the database connection is open or not. It just ensures you whether the database connection is open, yes or no. And that is what it is going to do. We have already discussed what it does is something called as lazy initialization, which means it is only going to open the database connection when someone actually tries to do it. Okay, and why do we do this? See, when the pipeline opens up, it imports many classes including the episodic store. And if we open the database connection in the constructor, every input would immediately try to connect to Cloud SQL, and we don't want that. That is the reason we are doing this. Okay, if you see, in case if it's not none, which means if the pool already exists, okay, then it is going to return nothing falsely. Okay, it's basically going to be falsy. Okay. Then we're going to work on create pool. And what does create pool do? It is going to create a group of database connections that stay open and ready to use. Okay, so when we say create pool, when we create a group of database connections, how do we create it? We take the host, we take the port number, we take the database name, we take the database username, database password. Minimum and maximum size, we're going to keep it 1 and 5. I think we have already discussed this in a previous session. Minimum size equals to 1 means keep at least one connection open at all times, and maximum number of simultaneous connections that you can do is 5. Now, episodic store is actually called less frequently than the vector store. Okay, and so 5 sessions or 5 connections is more than enough. Okay. And also one more thing, using fewer connections is also going to reduce the Cloud SQL load. Then we're going to create the init connection. Okay, and basically init connection tells our async PG that run this function on every new connection. So on every new connection, this is going to be run. Okay, and then finally we just say episodic store has been created. Okay, and all these things also get logged. Then we're going to define a static method. Okay, first and foremost, what is a static method? It's basically a method that belongs to the class but does not have access to the instance or the self or the class itself. Okay, so what is normal method? This is how a normal method looks like, right? It has access to all of the, your basically your instance, self and stuff. Static method, it has no self, it has no access to instance variables. But why are we using static method here in the first place? If you look at the init connection, it does not need access to any instance variables. It only works with the connection parameter is passed to async PG. And that is the reason we are doing this. So we're going to create static method. We're going to create asynchronous init method. It takes into consideration the connection parameter, okay, or the async PG. It's basically the connection. Okay, the connection that we're talking about must be async in nature. Okay. And what does this function even do? It registers the custom PG vector codec on a connection. What is codec here that we are talking about? Codec is nothing but pair of functions. What functions? Encoder and decoder. We had discussed this earlier. What does encoder do? It converts Python data to database format, and decoder converts DB format back to Python readable data. So why do we need a custom codec for vector? PostgreSQL knows about the vector type. Okay, but async PG is a generic driver. It only understands your standard PostgreSQL text types. It doesn't, your async PG doesn't understand what a vector is like, and that is the reason we need a custom codec. Okay, so without registering this codec, the writing and reading is going to give us, the read and write operations are going to give us error. Okay, so with codec register format, you're able to read and write properly. Okay, you can see we are setting the type codec. Okay, you're going to see we are setting it to vector, which is the name of the custom type. Okay, we're going to set up the encoder, we're going to set up the decoder. Now here you can read it in the comments. We have already discussed this in the last session. We're going to keep the schema as public. And I'm going to create one more helper method called as embed. The name itself is very self-explanatory. What it is going to do, it is going to convert any text string into 1536 dimensions. Okay, so it is going to use the OpenAI embeddings model. It is going to use it here. You can see here. Yeah, it is going to take the input text. Basis that, from the response, okay, we can see that we're just going to check the embedding of the first response that we get. Okay. Then we're going to define a public method called as save episode. It is very self-explanatory as to what it will do. It is going to save the episodes. But when it is going to save the episode, again, it is going to be asynchronous. When it saves the episode, what all things it is going to take into consideration? Agent name, content, NCT ID, outcome, which means what happened as the result of the investigation. Okay, and it is going to give us a string output. Okay, it saves one agent reasoning session as an episode in the Cloud SQL. What is going to happen inside save episode asynchronous method? First and foremost, it makes sure that the database connection is open. It generates a unique ID for the episode. It converts the content to 1536 dimensions. It inserts all of this into episodes table and it returns the episode ID. Okay, these are the arguments name that it is going to work on. Okay, first and foremost, it is going to call our private helper to make sure that the database connection is open or not. So we're going to call ensure pool. Yeah, ensure pool is going to say if the database connection is open or not. Then for every episode, we're going to generate a unique ID. Then we're going to take the content, okay, which is nothing but the content as in the episode content, and we're going to embed it. Okay, then we're going to say self.pool acquire. Okay, what does this self.pool acquire do? It basically checks out one connection from the pool. Okay, acquire says give me that one connection to use right now. So basically it is going to check if the connection is open or not. If yes, it is going to use that connection, as simple as that. And then finally we're going to use connection.execute, which means we're going to run a SQL statement to the database. Okay, so what does execute do? Execute is a method to insert, update, delete, basically CRUD operations. Okay, and then into the episodes table, if you can recall, we have created this episodes table. Now in this episodes table, we're going to populate all of this. Okay, episode ID, agent name, NCT ID, content, all of this we're going to populate. Okay, we are also going to give placeholders. I think we have already discussed what the placeholders do. If not, you can read it from the comments here. And these are the things we're going to populate. Episode ID, agent ID. Now to every table, you can see we're also giving a unique placeholder, which means agent name is at 2, NCT ID at 3, content at 4, outcome at 5, embedding at 6, etc. We're also going to take date time. Okay, then we're finally going to log it. So sorry for that. When the episode gets saved, okay, you can see that being logged here. Okay, and then finally what do we return? We return the episode ID. Okay, now what we can do is return the episode ID. It returns the unique ID, correct. It returns the episode unique ID, correct. Then what we're going to do is, once we have saved the episodes, we're going to search through those episodes. Okay, we're going to search through those episodes. So when we are going to search, for example, if a user query comes in, for example, first and foremost, it is going to take the user query, right? Then it is going to take the agent name. Okay, for example, let's say the user puts in a query, find the episodes where sponsor never posted results, or find episodes about Novo Nordisk, which is Novo Nordisk is a well-known pharma company. Okay, here it is going to take agent name, which means which agent is going to work on it, and the top K we're going to set it to 5, which means it is going to return how many past episodes. It is going to return top 5 past episodes, and minimum similarity 0.5, which means the minimum similarity score it should be is 0.5, which means it should be at least 50% similar in meaning. And what does it give in the output? It gives a list of dictionary. So what does search episode asynchronous function do? It's very self-explanatory. It is going to search through different episodes, okay, by the semantic similarity as compared to the user query. But what is happening inside this method? First and foremost, we should make sure that it makes sure that the database connection is open. Then it converts the query given by the user into an embedding. Then it builds a SQL query with optional filters, and then uses PG vectors, this operator, to find the similar episodes. And then basis that, it returns the top K, which is 5 most similar episodes. These are the agents it takes into consideration, and this is what it returns. What does it return? It returns a list of episode dictionaries. Okay, and each dictionary contains these fields: episode ID, agent name, NCT ID, content, outcome, similarity, and created at. It is going to make sure that the database connection is open. Then it is going to take the query. It is going to convert that into a query embedding. Whatever question is asked by the user, that also gets embedded. Okay, and then what do? We build a SQL query dynamically, which means we build a SQL query as a string, because different calls may or may not include the agent name filter. A fixed SQL string would need to handle all the combination, okay, and that is what we're doing here. We're just giving a query here, if you see, right? Select episode name, agent ID, all of that, okay, and created at, okay, all of that, you can just see here. I have defined the explanation as well. Okay, one means embedding one as a similarity and whatever explained. Okay, you can just go through this. Okay, now this operator that we are using here is pg vectors cosine distance. Okay, it compares the embedding column that is stored in the db against one as in whatever placeholder whatever item we had at placeholder 1. Okay, 0 0 means identical, they have same meaning, same direction, and 2 means they're opposite. 1 cosine distance converts to cosine similarity. Okay, this flips the scale so higher, which is most, this is just the cosine similarity. Okay, so there's 1, there's 2, 0 and there's yeah, absolutely, yeah. And similarity is more intuitive than distance. Similarity of 0.85 means clearly relevant. Okay, if you see here, this is actually a SQL function that I'm writing. I've just commented it out. Okay, so that might be kind of confusing. So just do one thing, just focus on this part where you're going to select the fields, and then after that just focus on from. Okay, from episodes, where one, where it is basically where, now here I'm going to put a where filter, and this filters out episodes below our threshold, which means only episodes with similarity greater than equal to, so you can see here, greater than equal to minimum similarity pass, which means minimum similarity is 50%. Okay, all right, and then we're going to put in the parameters list. Now in this parameters list, parameters is what? It's a list of values, okay, that is going to replace 1, 2, 3 in the SQL. Now here, if you can recall, while defining, we have defined 1, 2 and 3 as placeholders, right? So this particular parameters list is going to populate it. At first placeholder you have query embedding, at second placeholder you have minimum similarity. Okay, now as we add more optional filters below, we add this to the list. For example, there is something called as parameter index equals to 3. Now parameter index tracks the next parameter number to use, next parameter index. Okay, so we start at 3 because 1 and 2 are already taken. See, 1 and 2 are already taken here, and each time we add a new filter condition, we add this parameter index. Okay, every single time. Now every single time you might put a different where condition, right? So all those where conditions are basically going to get populated here. Okay, it is going to take agent. Now for every agent name, okay, only add this filter if the agent name was provided. Okay, so what do we do here? Basically, when once the agent name is provided, it is going to take the SQL query and also going to add the agent. For example, it will take agent name and will add to that parameter index, which is the third one. We're going to finally append that agent name to the parameters list, and the parameter index gets incremented by 1. Okay, all right, one more example of a SQL listing you can see here. I'm just going to add a simple one more. You can see I'm adding one more condition here, which is order by, right? So whatever I can see, I'm just again appending top k to the parameters list at the top. Yeah, so we are just going to add different whenever a condition gets added, you can see add top k as the last parameter. You can see it matches the parameter index in the limit clause above. Yeah, all of this. Yeah, you can just read through this, you will understand. Okay, slowly and steadily. Then we're going to execute a search query. Okay, we're just going to check out one connection from the pool, okay, which is going to test. Okay, you can see connection.fetch SQL and params. Okay, now connection.fetch runs the SQL query and returns all the rows. Okay, and fetch, not execute. You can see we are using fetch and not execute. Okay, fetch is for select statements that return the data, and execute is to insert, like basically CRUD operations. This parameters that we are using here, it basically unpacks our list into individual arguments. What is the list? The list of parameters. For example, query embeddings followed by minimum similarity followed by agent name followed by the top k parameter. Okay, and the list of episodes. Now here, when I'm actually storing my episodes, you can see this is the list comprehension, a compact way to build a new list by transforming each item. You can see here I'm just building this as a list of dictionary. Yeah, basically it contains all of these things. I'm just going to iterate for each and every row in the rows, which is the SQL table rows. You basically when I want episodes, basically I want episodes in this fashion. This is how it will be stored. a list of dictionaries. Okay, so when it is going to be a list of dictionary, this is how the dictionary is going to look like. It is going to contain all these things. Okay, we're going to finally log it that episode search is complete, and this is the query given by the user. Now we don't want the entire query, just first 50 characters. If you want to put an entire query, put it, it's totally fine. Which is the agent we are using and how many episodes or results we found basis the user query, and finally we're going to return the episode. What is episode? Episode is nothing but the list of episode dictionaries. Okay, and then we're going to create one more function, async function called as get recent episodes, which takes the agent name and the limit. Limit is 10, which means we only want 10 outputs. Okay, now if the caller does not pass the limit, we return 10 episodes. Okay, and what does it give in the output? It gives a list of dictionary. But what does get recent episode does? It returns the most recent episodes, newest first. Okay, now you might say we already have search episodes. Why do we need recent episodes? Okay, now this finds the episodes by meaning. Okay, this method finds the episodes by time, right? So search episodes is going to find it by meaning, and this is going to give us the most recent memories, most recent episodes, and that is what makes it brilliant. Okay, so we're going to take two arguments into consideration, agent name and limit. And what does it return? It returns a list of episodic dictionaries. It will check if the pool, if the database connection is open or not. It will look at the agent name and it will run the SQL query. Okay, it will take the episode ID, agent name, all the fields from the episodes table, where the agent name is whatever placeholder, order by, and created at descending, which means the latest one as per the timestamp, and we just want the whatever limit to 2, whatever it is. Yeah, all right, you can see this is the parameters list, which is here this is the parameters list for this one, which is the name of the agent and the limit. Else you run this SQL query. Okay, all right. Now async with, it is going to acquire the connection, it is going to run the SQL query, and finally when it runs the SQL query, this is what it is going to return finally. Okay, which is this is going to be your latest episode. Your latest episode is going to contain these fields. Okay, finally one more helper function called as count episodes. The name is self-explanatory. It is going to count total number of episodes that are stored. Okay, so it is used by the health check endpoint to show how much memory the system has accumulated. Okay, again it does the same job. Okay, it is using fetchval. Now here when we are taking the connection, we are using fetchval. Fetchval is like fetch, but returns a single value instead of rows. So all we need to do, if you just take select count from episodes, it is just going to tell you how many episodes it is going to fetch. That's all. Okay, and finally we are writing a function which is going to close the connection pool and release all the connections, right? See, our job is done, right? We have extracted all the episodes. Now we need to release all the connections, right? And we call this when the application shuts down cleanly, and without closing, connections may stay open on Cloud SQL unnecessarily, which is going to help, which is going to cost you. So in Fast API, this is called as lifespan shutdown handler. It is going to check if the connection pool is created. If yes, it is going to close it, right? If it's none, then it is just going to, it's basically going to reset to none if it's a clean slate. If there's nothing working here. And finally, it is just going to log that episode store pool has been closed. So you can see it is quite an interesting interaction that happens at an episodic memory level. So I hope you are trying to understand how are we creating the memory here. We are using the Cloud SQL for populating the episodes table. At the same time, we're also using the PG vector, vector database, capabilities here. Yeah. So that is about episodic store. Let's now move to the, to the next memory that we'll be building. Yeah. Thanks.